Hi friends, I'm Dattaraj. I'm the author of the upcoming book Keras to Kubernetes: Journey of a Machine Learning Model to Production. And today I want to talk about a very important concept in machine learning and AI systems called bias. Bias basically refers to the internal assumptions that your machine learning model makes as it learns from training data. This is not something specific to AI system. In general, any learning system typically tends to have bias, uh, including human learning. I remember back in 2005 when I first moved to Virginia. I went to a friend's place, and his 4-year-old son came to me, and he was like, "Hey, Datta, you are from India. Are you a doctor?" So I was surprised, and apparently his mom was a nurse, and he used to visit the hospital a lot, and he used to see a lot of folks from India who were doctors. So that was kind of a unintentional bias that he was starting to build, saying that okay, people from particular country tend to be in this profession. So we see this pretty common in humans as we learn, and so also AI systems also start building this bias. Technically, if we see like a neural network has dedicated neurons called bias neurons. These neurons learn as the network gets trained, and they store some of these assumptions that help the neural network make prediction. So bias is important, but we need to make sure the bias that our model is learning is the right bias, and it is not learning any unwanted bias, and which is going to affect the predictions made by the model. So I did a quick experiment where I looked at natural language processing. I took some books that were available freely as part of Project Gutenberg, and I took two books. And in natural language processing, this group of texts called corpus. So I took two corpora, two different books, and trained two different models. These models were trained to analyze these words and create embeddings, which are called word embeddings, using a method called word to vec. Uh, and what this would do is, for every word, they will create a like a embedding matrix or a vector, and then we can use things like Euclidean similarity or cosine similarity to figure out which words are similar to each other. So I took two books. One was by Sir Arthur Conan Doyle, Sherlock Holmes Scandal in Bohemia, and the second one by P.G. Woodhouse, Damsel in Distress. And I trained my two models on this two corpus or corpora, and then said I took a word, general word woman, and said, okay, what are some of the words that are similar to it? So technically, this means that whenever, along with the woman, some of these words are used, they will be highlighted. And interestingly, for the Sherlock Holmes book, I saw describing a woman words like admirable, high power, honorable. Now here, these were like in this particular book, Sherlock is faced against his nemesis Irene Adler, and she, despite being a criminal, the way the writer has described her, he always praised her, and we see some of these words. So it kind of a model tends to get biased, saying positive things about the woman, while on the other hand, in Damsel in Distress, though it is actually talking about positive things like a love story with humor about a particular woman, but because of his sense of the way the author has written these books, the words that kind of strike out, like things like noisy, wrathful, so they kind of don't give like a positive vibe, but that's because of the sarcastic nature of the humor. So these are kind of examples where there is some bias that gets built in. So if I just use a single uh, book or a single corpus to train my models, I may get biased based on the content and the context of that particular topic or the book. So that's kind of the moral here. Like when we as data scientists build models, it is important for us to know, try to get a diverse data set so that we don't get specific biases. Now, in this example, it's okay. I mean, this is kind of just a proof of concept kind of thing, but this becomes very important when you build real world AI systems. Things like systems that can decide if a person has to be approved for a loan or no. So you should not be biased by unimportant factors. Uh, for those kind of systems, including things like models like self-driving cars. They should not be biased by non-important factors, and they should be focused on the task at hand. And that is a very important lesson. And finally, the role of bias, I would say, is kind of like a technical depth. It is important, but for technical depth is something that is used in software systems, where you kind of try to circumvent certain building your code, making it more scalable and extensible, and try to say you build up the technical depth. So next time you want to add features, because you have skipped certain steps, that code becomes unmaintainable, and you have to work more to add features. While if initially, if you had taken care of making it more scalable and extensible, that would not have been the case. So it's kind of like that. You don't want if you have less training data, you end up training on it and end up building models which have a bias. And then when you actually face problems in real world, you have to come back and retrain the model. So it's kind of like a technical depth that you're building for data science or AI systems. And it is important for us to be aware of the bias and make sure that we have enough data set to circumvent the bias. So these kind of things, like comparing your data science workflows with your software engineering workflows, that's what my book tries to talk about, Keras to Kubernetes, and it's releasing end of April. And I hope you guys read it and let me know how you like it. Thank you.